but about the Thevenin's theorem. In today's session, I am going to discuss about Norton's theorem. What is that theorem and how the problems are to be done, that we can discuss one by one. Yes, I would like to explain what is Norton's theorem and problems related to Norton's theorem. I will do that now. How that theorem is to be explained here now, but this theorem also not given much importance in the GATE. Suppose you are asked, you can do that now. Even in PSUs also, we are not finding that much frequently asking, but it is better to learn Norton's theorem also. Norton's theorem. If a student is in a position to do problems by using Thevenin's theorem, he can do easily Norton's theorem also. Suppose you are given any linear network. Suppose there is a linear network. The linear network is given. This network is given with resistors, inductors, capacitors, and dependent or independent sources are given. That may be voltage or current source. Then you can apply this theorem. Suppose here connected with a load. RL is the load. RL is the load. The purpose of this theorem is to find current passing through the load resistor. This current you can measure. Even you want to find voltage across this RL, you can find. Voltage across this load also you can determine by using Norton's theorem. Even if you want to find out the power dissipation across the load, you can determine by using the Norton's theorem. The students may ask a question, sir, these three parameters are calculated by using Thevenin's also. Yes, this is one more technique to determine current or voltage or power. Understand my point now. This is one more methodology only, we can say. Understand that now. But the current is required, load current you think it's so. By using Thevenin's you can find, by using the Norton's you can find, by using the nodal analysis you can find, by using the mesh analysis you can find, any one of the technique you can apply. That is your choice. But this is one of the methodology I can say now. In this case, what you have to do, the equivalent circuit of this is, its equivalent circuit is drawn as a current source. That current source is taken short circuit current, ISC. Short circuit current. Okay, good evening, good evening. But by using the but you need to calculate what is the short. Good evening then. Yes, you need to find the what now? Short circuit current here, ISC. And you must connect one resistor parallel to this. That is taken as a Norton's equivalent resistor, I can put here now. And a load is to be connected in between these two terminals. The load is to be connected in between these two terminals. That load is taken RL. So once this network is formed, current across RL you can find by using current divider formula. Suppose I ask, can you find current passing through the RL? IL. IL you will find by using the current divider formula, ISC into RN by RN plus RL. The formula you are going to apply to find out the load current. Once you know the current, voltage you can measure now. Current into resistance is the voltage. Power I square R, IL square RL. You can find the power also now. But how to find this ISC and how to find RN is more important here now. RN is very simple. But how you calculated Thevenin's equivalent resistor, in the same way you need to calculate this RN also. RTH and RN will be same. It won't be differed only now. How you calculated RTH in the last session? In a given network, wherever the load is given, that you have to remove. Load is to be removed. Wherever independent sources are given, they must be shorted. That means independent source means whenever the voltage source is given, you will short circuit. If there is any current source, open circuit. If there is any dependent source, that must be taken as it is only. Then find out the what now? Resistance across AB. For that I gave certain conditions how to find that RTH. RTH and RN are same only now. What about the short circuit current? Short circuit current means this is the given network. In the given network, load is to be removed and A and B must be shorted. A and B must be shorted directly. Load is to be removed and shorted and measure short circuit current. Load is to be removed. Yes, correct, exactly. Load is to be removed and shorted only now. What a load is to be removed means to measure what? RN or ISC. Can you say, Tushar? Load is to be removed. To find out the what? Load is to be removed and A and B must be shorted. Then you will determine the what now? Current ISC. That way you can get only now. Understand now? This is required. Now by using this theorem, we can tackle certain number of the questions. Understand now? You will understand easily now. The first problem I will give in your hand. Yes, a problem was given like this. Find IN or ISC. ISC, short circuit current, or IN. IN means what? Nortons current. You may give any name. Comma, RN I want. And also I want load current also. Current through the load. One simple problem starting I am giving here now. Here given with 12 volts battery. There is a 12 volts battery and 2 ohm resistor is connected here. 6 ohm resistor is connected here. This is 6 ohm. And 3 ohm resistor is connected here. The current passing through these 3 ohm and one more I removed. Load also I must connect. And the load here connected is 1.5 ohm is given. This point is given A, this point is given B. This is the given problem. One is a 12 volts and 2 ohms and 6 ohms, 3 ohms and 1.5. Very good. How we can find the required parameters of current, short circuit current, RN and IL. Initially, I would like to find the short circuit current. What you must do? You must remove the load. This load you remove and short circuit across AB. Alright, AB must be short circuited only now. I say the network is to be taken as it is like this. Here given 12 volts, here the 2 ohm resistor is connected here, 6 ohm resistor is connected here, 3 ohm resistor is connected this side. And wherever the load is given, that is removed and must be shorted like this. This current we need to take ISC. This is ISC. This current you can determine by different ways. How? 3 and 6 are parallel and series to 2 ohm. Then find the total current. By applying the current divider formula, you can measure ISC. That is one of the technique. Otherwise, you can do by some other way also. Some other way means you take this node voltage, that voltage is nothing but V. If you know the value of V, ISC equal to what? Voltage by 3 ohms. Directly you can get. Anyway, you can do now by reducing the circuit or directly by nodal. Okay, I will explain how to apply the nodal here now. As per nodal, this current plus, away from the node you take it, this current plus, this current equal to 0. What is the current across this 2 ohm? V minus 12 by 2. V minus 12 divided by 2. This current. What about this current? V by 6 I can put, plus V by 6. What about this current? V by 3 I can write directly. V by 3. Summation of all the currents equal to 0. Once you are getting the value of V, the measurement of the current becomes very simple. But here I want to take 6 as an LCM only now. You take 6 as an LCM. 6 is LCM. 2, 3 is 3V. 12 into 3, 36 plus V, 2V, that equal to 0 possible. 3V plus 4, 4 plus 2, 4 plus 2, 6V I will get here now. 0 into 6, 0, 36 I can get here now. And finally, what is V? 36 by 6. It becomes 6 volts possible. I got node voltage is nothing but 6 voltage. By using this node voltage, you can determine ISC directly. The short circuit current is nothing but current across 3 ohm. How you can determine? V by 3 directly. V by 3. V is nothing but the 6. Divide by 3, it becomes 2 amperes. Yes, we are getting short circuit current. What about next parameter? We need to calculate what is Norton's resistance. To find the Norton's resistance, what you have to do? Wherever the independent voltage source is given, that must be shorted. To find RTH, I say. To find RTH, wherever voltage source is given, that you short. 2 ohm resistance is to be connected as it is. This is 2 ohm. There is 6 ohm resistor this side. And this side 3 ohm resistor is connected here now. That means this is shorted, 2 ohm here, 6 ohm, 3 ohm. Wherever load is given, that is to be removed. Load must be removed. Load is to be removed. This must act as an open circuit. This is 3 ohm. Now, I wish to find what is RTH here now. When the view is made this side, you will get a resistance of this Rn. Rn or RTH all are same. Norton's equivalent resistance. How to get? When the view is made this side, you reduce from the opposite side. 2 and 6 are in parallel. This is 2 are in parallel. The net resistance is series to 3 ohms only possible. How we can simplify? Rn is nothing but these 2 are in parallel. 2 into 6, 12 divided by 6 plus 2, 8. These 2 are in parallel. And series to 3 ohm plus 3 I can write now. And I can cancel 4 2s, 4 3s. And finally, Rn equal to what I am getting? 3 plus 2 3 is 6 by 2 possible. 9 by 2 is possible. It becomes 4.5 ohms possible. The net resistance is possible. Rn is nothing but 4.5 ohms mostly possible. But once you are getting the what now, Rn value and also what IL also required, load resistance also required. You draw the Norton's equivalent circuit and find out the what now? Current IL. How we can find the IL value? Please watch it now. But I want to draw the Norton's equivalent circuit. Norton's equivalent circuit is required. Equivalent circuit is required. How we can draw the Norton's equivalent circuit? Here required one current source and must be connected with Rn, Norton's resistance here required, and also required here load resistor. They must be connected in parallel. But they were all connected in series means what happened now? Voltage source is connected series to the RT, but it becomes what now? Thevenin's rule. Anyhow, the current we got here is, ISC 2 amperes. This is 2 amperes given. Rn is nothing but Rn or RTH, both are same. RTH is nothing but Rn only. Both are same only. Rn and RTH same only now. Understand now. Thevenin's resistance and Norton's resistance both are same. Understand now. But we are getting Rn equal to what now? 4.5 ohms. 4.5 ohms. And load also given in the problem. Load resistor equal to how much here? RL equal to 1.5. This is 1.5 ohm. Now you can determine current passing through this RL. That is the load current only now. By using voltage divider formula, you can determine IL. IL equal to what? Apply voltage divider formula, current divider formula. 2 into, according to current divider formula, 2 into 4.5 by 4.5 plus 1.5 is possible. 2 into 4.5, 9 divided by 4, 5, 5, 6 is possible. 3 2s and 3 3s. Finally, load current is nothing but 1.5 amperes of current is passing through the circuits. So, this is the load current is possible. That way, you can determine current, even Rn, otherwise short circuit current now. I think you followed well about this question. Now, I want to give one more question in your hand by using the dependent source. You please try this question. I want to give in your hand now. But I will give in your hand just to try. If you are getting answer, very happy. If not getting, I will do. Find Norton's current. Find Norton's current. Is asking Norton's current. In the bracket I suffix n it is given. Norton's current IN as shown in the figure. As shown in the figure. This is given like this. In the figure, it is given. And here the network is given like this. There is one 4 volts battery and connected with 2K resistor. And also here given one dependent source. There is one dependent source. The dependent source is nothing but the current source it is given. This is the current source. That source is nothing but, that source is given as a what? Vx by 4000. Vx by 4000 it is given. 4000. And this is 3K resistor. This point is A, this point is B. Voltage across AB is given Vx. This is given Vx only now. This voltage is Vx. Yes, because this current source depends upon this Vx. You try to find IN value, thereby required Norton's current. IN is required. To find out the IN, AB must be shorted. Then you measure, but I want to give you time. Please make an effort to get answer. Start doing this question. What way we can do this question? Anybody? What is the answer? Please tell me. What is IN? What IN is possible? I am not going to give any options. I would like to know how you are going to do this question. Can you do it? Okay, I will do. Please cross check your answer. What you have to do at first, to find out the Nortons current, AB must be shorted. Load is removed anyhow, load is not given. You have to short circuit. I will draw the circuit in this way again. There is 4 volts battery, 1 voltage source is given. Here connected with 2K resistor. But in this case 3K resistor is connected here. This AB is shorted directly. This current is ISC. Now please watch here. Whenever A and B points are shorted, what is Vx here? Vx means voltage across AB. This is voltage across AB. That is the Vx. What Vx you will get from the given problem? Anybody? When you shorted, what Vx you will get? Anybody? Anybody can respond? If I short circuited A and B, what voltage I can get across AB? 0 voltage only. We cannot find any voltage across this. We don't have any resistor here now. So we can write Vx equal to 0 voltage only. In case Vx equal to 0, this voltage becomes 0 only now. If it is a 0, 0 by something, 0 amperes. 0 amperes means what is the meaning? This branch can act as a open circuit only now. Current is 0. This can act as a open circuit only. So totally you can remove this branch. You can remove this branch. Exactly correct, Manoj Kumar. 0 is possible here. In this case, you can determine what is ISC. Just it becomes a what now? One closed path you are getting directly. So ISC is nothing but 4 by 5K you can write directly. 0.8 amperes, milliamperes of current is passing now. This much amount of the current is passing through the network now. That is answer. This is ISC. 0.8 milliamperes of current is possible. Exactly correct now. It is a open circuited. Very good. Very perfect. That's all answer. Very simple. And I wish to give one more question in your hand. You please try. Find. Now you please try this question. Find IN Nortons current I want, and also RN Nortons resistance required. Nortons resistance or Thevenin's resistance, both are same only now, I said already. And the network is given here, 20 ohm resistor here, with a dependent source it is given, with a dependent source, 20 ohms, 10I, dependent source is given, 10I. This is 10I. Load resistor RL is connected here. This is R suffix L. And 40 ohm resistance is connected here, 40 ohm resistor is connected. And 50 volts battery is connected here, 50. But the current passing through this 40 ohm is given small I. So this dependent source depends upon the current passing through this 40 ohms I. Understand my point now? But this is the point is to be taken A. This point is given B. So I want current across this AB. Sorry, current across this AB whenever it is short. If the load is shorted, what is IN? And if RL is removed, open circuit, resistance also required now. Resistance across AB when load is removed is needed now. Can you try this question without my help? Can you try? Anybody can try this question? But I want to wait. You please try. What is IN? You calculate at first. What is IN? IN or ISC, both are same. IN is nothing but the Nortons current, otherwise ISC, short circuit current, both are same. So, okay, I will also do here now, please watch. But in this problem, IN or ISC both are same, I said already. IN or ISC both are same. Nortons current or short circuit current both are same. Wherever the load is given, that is to be shorted directly. Load is removed and short circuit. Here the solution we can take. There is 20 ohm resistor here and here connected with a 10I. This is voltage source, 10I is given here. The load is to be shorted, I said. Yes, that is shorted like this. 40 ohm resistance is given, 40 resistor is connected here. Here a voltage source of 50 is connected here. 50 volts here connected. The current passing through this AB is to be taken as a what? IN or ISC. IN or ISC. Choice is yours. Such a way I can take now. That current is required. The current passing through this side is I. We know very well. How you can get that IN? But one reference what now node is required. This reference node I want to take it as a 0 voltage only. Grounded only now. If it is shorted, this voltage must be 0 voltage only. This is 0 means same 0 you can find here now. Because it is a reference node only here now. By using the nodal analysis, I can determine what now? This current I. This current I want to find now. Once you got the I value, then you can determine the what now? IN also now. First, by using the Nortons what now? You can, but using the nodal you can find IN. I also not required. IN is required. How you can determine that IN? As per the nodal, this current plus this current plus this current equal to 0. In before that, what is that I? You calculate. I equal to what we can say? Current across 40 ohm. 0 minus 50 by 40. I say current I is nothing but 0 minus 50 divided by 40. I can write. Finally, I am getting minus 5 by 4 I am getting here now. That much I is possible. Minus 5 by 4 I am getting here now. That much value. But my aim is to find IN. By using the nodal, this current is nothing but 0 minus 10I. 0 minus 10I divided by 20 ohms plus this current is IN, Nortons current or short circuit current, both are same. That current is required. Yes, one student Manoj, he gave minus 5 by 4. What is minus 5 by 4? Minus 5 by 4 is I, is it not? Yes, that only I got. I equal to minus 5 by 4. But my aim is to find out the what? My aim is to find out the current passing to what now? Nortons current I want here now. IN. This is IN. This current is nothing but what? 0 minus, already we got now. This current is I. This current is I. Summation of all the currents equal to 0. I value we know minus 5 by 4. You can substitute. Minus 10 into I is nothing but 5 by 4. 5 by 4 I can write now. 5 by 4. IN I want to find. I is nothing but minus 5 by 4 again. Summation of all the currents equal to 0 only now. but here the 4 is LCM here now. Otherwise, IN equal to, we can find directly. IN equal to 5 by 4. If you brought this side, this becomes a 5 by 4. If you brought this side, but the 1050 by 4 is possible. So 55 by 4 is possible. Use calculator and tell me what answer is possible. Use calculator and get the answer. Minus 10 into 20 is there one more, sorry, this 20 I have not taken out. 0 minus 10i, 10i by 20 is there now, sorry, by 20 is there now. The 20 is there, is it not now? Yes, slight change is there now. But here we have to take this also, is it not now? 0 minus 10 into I is a 5 by 4, minus 5 by 4, minus of this minus, plus is possible here now. This is a minus. The 20 into that much you got here now. IN we need to calculate. I equal to 5 by 4. Now we can find directly. 10, 10 2s you can cancel. 10 2s I can cancel now. 5 by 8 is possible here. And this side what I can get now, minus 5 by 4 I can get. That equal to IN I can put. Now you can find the IN value. I want IN value. How you can measure IN? So I can get directly IN equal to 8 is LCM here. 5 minus 4 to 2 5s 10 is possible. 2 5s 10 possible. Minus 5 by 8 is possible. That much amount of the current is passing through this side. So short circuit current equal to minus 5 by, yes, minus 5 by 8 only possible here now. Yes, minus 5 by 8. That much value possible. 5 by 4, is it correct? Check it again. 5 by 4 IN means this side plus 5 by 4 possible. You know, reversely it is taken. Yes, now correct. Yes, now perfect only now. Yes, 100%. Now okay. That way you can measure now. But I want to give one more question in your hand. You please try this now. I will give. Next problem I will give. But I want to give one more question in your hand. Please try it. Find Rn. Is asking to find Rn. Find R suffix n. Nortons resistance is required. The given network is, for the given network it is given, for the given network, NW, network I have taken now. And here the network is given 10 volts, source is connected this side, this is 10 volts. Here connected with 2 ohm resistor, 2 ohm resistor. Here connected with 4 ohm resistor. This is 4 ohm. And this side 1 volt battery is connected here. This is a 1 volt battery here connected. And 2 ohm resistor is connected this side. 2 ohm resistor. And 4 ohm resistor is connected this side. And also connected here 2 amperes current is connected this side. This is 2 amperes. And here 2 ohm resistor is connected this side. This is a 2 ohm. And here connected 2 ohm. This point is A, this point is B. This point is B only now. Will you get answer for this? Is asking to find the Nortons resistance. Please try this question without my help. I'll see how many students will do this question. How many students will do this question? I will see. Can you give answer? Any student can do this question? How the solution is to be calculated from this problem? But this problem is a very simple. It's not complicated here now. Why means, please watch. I will do here. But in the problem, what is required? Nortons resistance is required. As per this Nortons resistance, what is given here now? This voltage source must be shorted. This 2 ohm is to be connected as it is. The 4 ohm resistor is connected this side. This battery is to be shorted and 2 ohm resistance you got here now. Here connected with a 4 ohm resistor. But that side, one current source is connected here now. Voltage source means you need to short circuit. If there is current source, what you must do? Yes, 44 you are giving. What is 44? What is 44? May I know? Manoj Kumar, you gave 44. What is that 44? Are you saying Rn value? Do you say Rn? Manoj Kumar, can you say 44 is Rn? Yes, I will do anyhow. Please watch here now. This is a 4 ohm I connected here now. This current source is to be open circuited only now. This is open. And here I got one 2 ohm resistor. And this side one 2 ohm is connected here now. This is A, this is nothing but the B only now. This is A and this is B only. But yes, you are saying Manoj. You please watch. Whenever this current source is open circuited, this will be useless only now. This will not be useful. But I want the resistance across this AB only now. That is Rn. Resistance across AB only required. Resistance across AB means these two are in series. These two are in series. This network is not connected. It doesn't have any effect. These values will not have any effect because of this open circuit. When you are extending just A and B, you are pulling means these two will come in series only. If you are pulling A and B, but the 2 ohm will come in series only. Directly we can write Nortons resistance is nothing but 2 plus 2. It becomes a 4 ohms only. It doesn't have any effect because of the what now? Open circuit only. I can say that. Understand now. That is answer. Yes, Manoj, 4 is a correct only now. Your answer is a perfect now. Understand now. Yes, I want to give one more question in your hand. You please try this question. One more good question I will give now. The next problem is given Norton's equivalent circuit. Sorry, Norton's not. Find IN and RN. Sorry, find IN. IN means short circuit current. I want. Find IN and RN. RN means Norton's resistance. These two values are required. The network is given for the given network. For the given network. The network is given here now 24 volts here connected. 24 volts. And here connected with a 4 ohm resistor. 4 ohm resistor. And there is a current source of 4 amperes. This is with 4 amperes of current. These 2 points are connected this side. And 4 ohm resistor is connected this side again. And 8 ohm resistor is connected this side. There is one 8 ohm resistor. A and B are open. This is A, this is B. Now, will you calculate Rn and IN? IN is nothing but the short circuit current. Please try this. These two parameters are required. Please compute these two parameters from the given problem. You please complete these two parameters. The Manoj, Rn is 4 ohms. Yes, I will check. Rn equal to 4 ohms. That's correct. Exactly correct. Rn equal to 4 ohms. What about ISC? What about ISC? Short circuit current. The Rn is very direct. Nortons resistance you can determine very directly. How you can find the resistance here? To find the Rn, wherever DC voltage source is connected, that must be shorted. Here I got 4 ohm resistor. Wherever current source is there, independent current source, that must be open circuited. If it is open circuited, I will get 4 ohms this side. These are 4 ohms and 8 ohms here connected. And this A point, this point is a B point. I want resistance across AB, that is Rn. These two are in series and again parallel to 8 ohms. I can write 4 plus 4 is a 8 parallel to 8 ohms. The 8 parallel to 8 means 4 ohms here possible. Yes, I am getting the resistance now. I got the resistance. I wish to find what is IN. To find the IN, I can redraw this network. What I can do, as per the nodal analysis, we can get easily now, this point only now. How we can find? You should short circuit at first this now. I can redraw this circuit like this now. I will redraw. I got here now 24 volts battery. 24 volts here connected. And 4 ohm resistor is connected this side. This is 4 ohm. Here connected with a current source. That current source is given as a 4 amperes. This is with 4 amperes. And also connected here, the 4 ohm resistance this side, there is one 4 ohm resistor. And also we got here now one more resistor. The resistor is nothing but 8 ohms. This is 8 ohm resistor. This is connected directly here now. This current is nothing but the Nortons current only now. But can you find any current across these 8 ohms? Anybody can say? Is it passing any current across 8 ohms? Is it passing any current across 8 ohm? Anybody can answer? Can you find any current across that 8 ohms? Please tell me. Is it going to divert any current across these 8 ohms or not? The current will come through the 4 ohms. Then is it diverted any current across 8 ohm or not? I am asking here now. No, exactly correct. It doesn't flow any current across 8 ohm because this is shorted. Whenever it is a shorted current through the 8 ohm is what? 0 amperes only. At the time, redundancy technique is applicable. You can remove these 8 ohms also. Even you removed, it doesn't matter now. Even you removed, it doesn't matter now. 8 ohm, it doesn't pass any current through the 8 ohm only now. And you can determine the IN value. How I can determine? This is a 4, but by using the nodal, you can find directly. V you determine. Once you got the V value, you can determine the IN. Any method you can apply, nodal or mesh or anything here now. By using the nodal, this current plus, this current plus, this current equal to 0. This current is V minus 24 divided by 4. This current is minus 4, this side. And that side current is nothing but V by 4 I can put. Summation of all the currents equal to 0. The 4 is LCM here now. I can put here now. V minus 24 here. 4, 16 I am going to get here now. Plus V that equal to 0. And finally I am getting now V plus V, 2V I can get here now. 20, 30, 40 is possible. Minus 40 equal to 0. And what is V here? 40 by 2 is nothing but 20 volts I am getting here now. The V is nothing but the 20 volts. In that case, you can determine the IN value. Yes, you are getting IN 5 amperes. Exactly correct. Exactly correct. Then an IN is required. IN is nothing but the current across these 4 ohms. IN is nothing but V by 4 I can put now. V is nothing but what? 20 divided by 4. I can get 5 amperes of the current in this direction now. Yes, we got IN equal to 5 amperes only. That way you can determine this current. But I wish to give one more question now. Use your brain and give answer. The next question. You please try this question. Norton's equivalent circuit is asking Norton's equivalent circuit. Norton's equivalent circuit. Norton's equivalent circuit as seen from the the terminals A and B will be the network is given here now. 2 amperes of current is passing this side. This current is 2 amperes. And here I got 2 ohm, the current is in down direction only. It is passing this side. This 2 amperes is passing this side. And here the 2 ohm resistor is connected. Two amperes I got here now. Here I got one resistor. The resistor is given 2 ohm. And here connected with 1 ampere current source. This side it is passing 1 ampere current source. And 2 ohm resistor is connected this side. This is with 2 ohm resistor. This point is A, this point is B. This is the given problem. But he gave the 4 options. 4 options, 4 diagrams are given. I will not give any equivalent circuit. Please try to get Norton's equivalent circuit for the given problem. This is 2 amperes. This is also 2 ohms, 1 ampere, and 2 ohm it is given. Can you complete this question without my help? Anybody can complete? Anybody can complete? Okay, you complete this question. You try as a homework only now. Yes, thank you.